Okay, we have here an interesting integral. This one's from the Columbia Integration Bee 2025, number 16. We have the integral from minus 10 to 10, x squared over e to the x plus 1 dx. Okay, this is the kind of problem that comes up a lot on a lot of the different integration bees, and I think we'll do it a different way. What I want to do here is we'll generalize it. We'll notice that this, here's an even function that we'll call, in general, we'll call it f of x for our even function. The exponent here is going to be, we'll call this g of x, and that's going to be an odd function. And we'll also notice that we've got our bounds. Our bounds are symmetric around 0. So what I can do is create like a different integral. We'll call this like something like minus a to a. And we're going to be integrating f of x, where f of x is even. We'll write it this way, 1 plus, not necessarily e, we'll just call it some constant. Let's call it b, so we're not confusing it with a plus c for some reason. So we'll do b to g of x, where b is a constant and g of x is odd. And then to integrate this, what I can do is use King's principle, or you could do a u substitution. Like if you did a u substitution, I would do u equal to minus x. But for King's principle, we use f of a plus b minus x, where a and b are the bounds. I mean, it's confusing with the variables I used, I guess, but really what it's saying is we add the bounds and subtract x, but when we add the bounds, it's 0. So really what we're looking at here for our King's principle is just f of minus x. So when we do it with King's principle, the bounds stay the same. So what we're going to get is an integral from minus a to a. We're just going to plug in input a minus x everywhere. So we're going to have f minus x. I probably should, the notation's kind of weird. Like I should have used something different here, right? Because we have f of x in our problem. Here, we'll call it h of minus x, where the function's going to be this whole thing. So we just want to plug in minus x everywhere. So we have f of minus x in the numerator. We get 1 plus b to the g minus x. But then we can just use the definition for odd and even functions. An even function, if we input minus x, it's the same thing as f of x. So we can just put it back like that. And then for an odd function, if we have g of minus x, that means we can take the minus out front like this. So notice that we have something here that's really similar to our original problem, but not quite. We have the minus sign on this exponent. So in order to try to get it back looking like this, I can just multiply by 1, multiplying in this thing. So when we do that, let's see what we have, because it's going to be pretty nice, because b to the g of x times 1, that's just going to be b to the g of x. Here, this thing times this thing gives us 0 exponent, so we just get a plus 1 here, and it's going to be over all this stuff like this. And now all I want to do is just add 2 copies of the integral. This thing is the same as this thing. We can call it I. Yeah, let's just put an I on it. So if this is, in both cases, both copies are going to be I. Then we add them together. We're going to have 2I. We have the same bounds, minus a to a. We've got the same denominator, it's just in different orders, right? So we can just put these we can put it all in one fraction with the same denominator. And then when we add numerators, we can factor out an f of x. So we factor out f of x. Here, like think of this like a 1, so we have 1 plus b to the g of x. But then the payoff we get is this is always the same as this. So that goes away, and we're just left with this f of x function. Now, one other thing we can do is we know f of x is even, so we can use the principle of even functions with symmetric bounds, right? We're symmetric there, so we can make this a 0, bring a 2 out front, and then we can just divide off 2 on both sides, and we've isolated our integral. So what we're left with is an integral from 0 to a of f of x dx. So we're not done, of course, but we have a nice formula that's going to allow us to reduce this thing and go directly from here to here in one step, and that's going to make it quick to solve our integral. So let me clean it up and we'll start in our actual problem. Okay, so to get started with it, directly to the formula where our a value is going to be 10. So we'll take our integral and reduce it. We're going to be going from 0 to 10 of just the f of x. So we're just integrating x squared. Well, pretty much the easiest integral in the world. We just integrate it, evaluate, 0 is nothing, plug in 10, 10 cubed is going to be 1,000 over 3, and that's it. Okay, so there you go. As you can see, it's a very simple integral after you use the formula. It's not, I mean, it's not terrible if you just did it out, but you can definitely save some time just integrating x squared. Okay, that's it for today. Thanks everyone for watching. Have a good day.